This is part 2 of the narrated series of videos to accompany my GCSE Science Sprint series of shorts. If you haven't found the shorts yet, you can see them on YouTube Shorts or TikTok, but in these longer form videos, I'm just talking through the exact same exam questions, but in a bit more detail and explaining why I've done what I've done, which I think is particularly important for these chemistry calculations. So in this question, we're given masses of propane and oxygen and asked to calculate a mass of carbon dioxide. Now, with these quantitative chemistry questions, the very first thing you need to do is to identify what type of question it is, because it would be really easy for you to look at this and decide it's a theoretical yield question and go straight into that. But actually, it's not. This is a limiting reactant question, and the way that I can tell that it's a limiting reactant question is because I've been given the masses of both of the reactants, and it's not possible to work out a yield using both of those. So my very first thing is going to be that I'm going to need to figure out which one is limiting. Now, to be fair, this is quite a hard question. It's very, very rare on a GCSE paper to see one which simultaneously asks you to work out the limiting reactant and work out the theoretical yield. But it's well worth you learning how to do this. So we're going to go for it, even though it's a bit tricky. So the very first thing that we're going to do on our exam paper is a little bit of housekeeping, which is that we're going to write down the masses of the reactants alongside the things that are reacting, like this. Now, this seems really straightforward and obvious and a bit of a waste of time, but you would not believe the number of times that I've seen people work out an incorrect number of moles because they've mixed up which mass went with which chemical. So if you just do this at the start, it's just going to save you a headache later on. So now that I've done that, whenever you have a quantitative question, even if you're not sure what to do, there is almost always a mark for working out the moles of something. So in order to work out some moles, or we've got some masses, we're going to need some relative formula masses. In other words, the mass of 1 mole of each of those substances. So I'm going to start with propane, just because it comes first. And to calculate the relative formula mass, or the MR, we add together the masses of all of the different atoms that are in that compound. So for instance, carbon has a relative atomic mass of 12, and in my propane molecule there are 3 carbon atoms, so I do 3 times 12 and so on. And I work out that the relative formula mass of propane is 44 grams per mole. So 1 mole weighs 44 grams. But I don't have 44 grams, I have 20 grams. So I need to do a little bit of calculating to figure out how many moles that would be. So you probably know a little equation, mass is Mr. Mole. If I rearrange that, I get that moles is going to be the mass divided by the MR, or divided by the relative formula mass. So I do my 20 grams divided by 44 grams per mole, and I get 0.4545 blah, 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 blah. Now, I haven't written out the full calculator display here, but that doesn't mean that I'm rounding at this point. You should never ever round until you get to the very end of the calculation, because it can have quite a big impact on your answer, and you could end up doing all the right procedures but still getting the wrong answer. So I would use the answer button on your calculator if you've got one, but if you don't have one, then just write down your full calculator display and put that back in later. So that's my moles of propane. Next up, moles of oxygen, and to do that I need an MR of oxygen. So this is quite straightforward because it's just this diatomic molecule, so 2 lots of 16 is 32, and then I do the same thing again, 70 divided by 32 is 2.1875. So now I've already earned myself 2 marks, and now I need to figure out which one of these reactants is limiting. Which one do I not have enough of? Now that's not as straightforward as saying which one do I have less of. If I had a reaction where they were reacting in a 1-to-1 ratio, so for every 1 propane I needed 1 oxygen, then yes, I could just look at which one was there less of. But that's not what I've got here. I've got this 1-to-5 ratio. If I look at my equation and I look at the coefficients in front of those chemicals, you can see there's a 5 in front of the oxygen and there's nothing in front of propane, because chemists are lazy and we never write the number 1. So you can just imagine that it's there, right? These are reacting in a 1-to-5 ratio. And so that means that if I'm going to have 0.4545 blah moles of propane, I'm going to need 5 times more moles of oxygen, which happens to be 2.2725. Now, if I compare that to how many moles of oxygen I've actually got, you can see that there isn't enough. I haven't got as many oxygen molecules as I've said I'm going to need. And so that means that oxygen is my limiting reactant. Now this is important because now we're going to go on and work out theoretical yield, and to do that I always use the limiting reactant, because I can't use my moles of propane because I don't have enough oxygen for that reaction to happen. So I'm going to go back to my equation, back to my coefficients. 5 moles of oxygen reacts to make 3 moles of carbon dioxide. But I don't have 5 moles, I have 2.1875. So I need to use those coefficients again to figure out how many moles of carbon dioxide I'm going to make. So last time it was quite straightforward because we were just timesing by 5. This time I'm going to make it really, really obvious. So I'm going to divide by the coefficient in front of the thing I already know about. So I already know about oxygen. I divide by 5 because there's 5 in front of oxygen. And then I multiply by 3 because there's a 3 in front of carbon dioxide. So you're always dividing by the thing you already know about, multiplying by the thing you're trying to work out. So in this instance, that gives me 1.3125 moles of carbon dioxide. Great. Except I don't need to know how many moles there are, I need to know what mass there is. So I go back to my old friend, mass is Mr. Mole. And again, I'm going to need a relative formula mass, or MR. So carbon dioxide, 1 lot of 12 for carbon, 2 lots of 16 for oxygen. Also, coincidentally, is 44 grams per mole again. And so if I multiply that by my number of moles, I get 57.75 grams. So at this point, I've probably got all of the marks in this question, but as we know, AQA are a big fan of throwing in an extra maths mark. So they might specifically say to you that they want it to a certain number of significant figures, but even if they don't say that, the rule for all of science is that you can only be as precise as your least precise data. So if I look at my question, they've given me the masses to 3 significant figures, and so really I should give my answer to 3 significant figures. Now AQA are usually pretty good at actually telling you to do this, but in this instance I haven't included it in the question, we're just going to do it anyway. So you need to look at your first 3 significant figures, and then you use the 4th one to decide whether to round down or round up. In this instance, my 4th figure is 5, so I'm going to round up. So that means my final answer is 57.8 grams to 3 significant figures. Thanks very much for watching, and I hope that you'll come back on Friday for the first physics short in this series. If you did find this video useful, then don't forget to like, subscribe, comment and share, as all of these help me to grow the channel. And I'll be back with some more GCSE Science soon.